So in raw milk, casein is organized in micelles. Here you can see a simplified representation of the casein micelle structure. The micelles have a diameter ranging from 100 to 200 nanometers. So this is a large protein, in fact, and that's because casein is, in fact, an aggregate of protein. Casein micelles are made of 4 different casein units, some hydrophobic, namely alpha S1, alpha S2, and beta casein, and one is hydrophilic, the kappa casein. In the structure of the aggregate, there is a specific distribution with the hydrophilic casein, so the kappa casein, located specifically at the outer layer of the macrostructure. And this is how a particle which is made up of mainly hydrophobic components is turned into a water-soluble protein. Another specific characteristics of the casein micelles is their high content in calcium and phosphorus. This is due to the calcium phosphate, which binds to the amino acid residues, contributing to the cohesion of the aggregate. Now, let's have a look at the transformation of the milk into cheese. Milk is a liquid solution of casein micelle, and it gets changed into a gel after adding the rennet. Rennet hydrolyzes the glycomacropeptide, called GMP, from the kappa casein. This alters the hydrophilic-hydrophobic balance of the whole casein micelle. The attractive hydrophobic interactions become more important than the repulsive interactions, allowing the caseins to aggregate. In cheese making, the whey is separated from the cheese curd. In the whey, you will have the globular proteins, also called whey proteins, and the GMP. And in the cheese curd, you will have the aggregated casein. Processed cheese making is in fact a second transformation of the cheese. So let's see now which kind of transformations are involved during processing, during processed cheese making. The chemical action of the melting salts combined with heating and shearing leads to 2 transformations. At first, the peptization. This is a destructuring mechanism. Divalent calcium ions are exchanged with monovalent sodium ions or potassium ions from the melting salts. And this ion exchange breaks the ionic bridges within the casein structure. And it causes the micelles to open and finally to aggregate, to dissociate. And this leads to liquefaction, as you can see on the picture in the illustration. The second transformation is the creaming. This time, this is a restructuring mechanism. At hot temperature, the strengthened hydrophobic interactions between protein cause an aggregation of the casein subunits. And this aggregation leads to a viscosity increase, as you can see again on the picture to illustrate what's happening. This slide is just showing you the effect of the melting salt. This is an experiment that we did in the lab. We added increasing amount of phosphate into a solution of micelle casein. And you can see on the left, so we start from a white solution, turbid and white solution, and progressively the solution gets completely transparent with increasing amount of melting salt. And this is due, in fact, to the size reduction of the casein as a result of the peptization. The casein particles become eventually so small that they do not diffract the light anymore, making the solution transparent. So now I would like to review with you the technological parameters which are impacting or potentially impacting the peptization. The first one is the accessibility of the melting salt to the proteins. In fact, yes, the melting salt have to be in contact with the protein in order to put in place the ion exchange. Then the second parameter is the type of melting salt, the type of protein, sorry, excuse me. Of course, we've been explaining that before, the peptization works with casein. So the ratio casein to whey is important, casein to whey protein is important, and even the source of protein is important. For your knowledge, with rennet casein, for instance, you can expect a rate of peptization of 100%, 100%, so complete peptization. This is not something you can attend with, you can reach, sorry, with cheese, because with cheese, the casein will be peptized to only 80 to 85%. The third parameter is the type of melting salt. Indeed, you can use different types of melting salt. You have the possibility to use citrate or different kinds of phosphate like orthophosphates, pyrophosphates, or polyphosphates. And in fact, to make it short, the melting salts which are efficient for peptization are polyphosphate and citrate. The pH is also important. So the higher the pH, the more intense the peptization can be. And finally, the temperature and heating time. The higher the temperature, the longer the heating time, the more intense the peptization.